Compound inequalities involve two or more inequality symbols at one time. And so it can break the number line up into two or more parts. And or if we had just one enclosed part, that also is a compound inequality. So let me start with that first example. And suppose we wanted to represent the numbers between 1 and 4. And I'll include them this time. So I'll put the closed circles. And it would take two inequalities to describe this. First of all, to the right of 1, greater than or equal to 1, would be x is greater than or equal to 1. And that would describe all the numbers starting at 1 going to the right. But I stop at 4. And I also need numbers to the left of 4. And so we could say that, well, but also x is less than or equal to 4. But how do we resolve this? Because these numbers are greater than 1, and these numbers are less than 4. But what I need to do is restrict my numbers between 1 and 4. And we do that with the word and. So the word and is the logical conjunction, which means that both of these must be true. So in order for a number to appear in this set, suppose number 2 I'm thinking about, is number 2 between 1 and 4? Of course it is. But 2 satisfies this inequality. 2 is greater than or equal to 1. And it also satisfies this inequality. 2 is less than or equal to 4. So both places at one time. So that's what and means. It has to satisfy both of them simultaneously. Now a number out here, for example, 5, does not belong, because although 5 is greater than or equal to 1 is true, it's not also true that 5 is less than or equal to 4. And so 5 only satisfies one of these conditions. Well, and here I like to introduce the words and or. They're the two big logical conjunctions that you should learn about in math. And math is not the only one who uses these and ors. And or is used the way we're going to use it here. It's used in computer science. It's used in electrical engineering, and it's used in law. Lawyers have to agree on what these words mean precisely. And so there are several constituencies that have to interpret these conjunction words we're going to use, and then the next one is going to be or in a minute. All right, so and means both at the same time. Now, we can write this as a compound inequality this way. We could say that 1 less than or equal to x less than or equal to 4. And I would read it basically as looking at, I would say this x lies between 1 and 4 inclusively. And so, or you might think of it as a sandwiched in between. This is all the numbers between 1 and 4, including 1 and 4, including the endpoints. So we can, and it makes sense to take these two separate inequalities and combine them into a single one. And this is what we typically work with when we apply this. In our next section, we're going to apply these compound inequalities. As far as interval notation, we would say, okay, well, x belongs to the interval from 1 to 4. So I'm going to write it this way, using brackets, because we're including the endpoints. So x lies between 1 and 4, that way. So there's an example of an and inequality, compound inequality, and it results in a single interval. Now we're going to look at the other type of, basic type of compound inequality, which results in split intervals. And both of these show up in our next section. Anytime you're dealing with distance, you could say, well, something lies within a certain distance of a point. It lies in this interval. Or you could say, well, something lies a distance greater than a certain amount from a particular point. It lies outside that radius. And so those two situations create two types of compound inequalities. All right, so let me give you an example of that. And let me show you on a number line first. So this time I'll go about it a little differently. Suppose I have, I'm just making up numbers. Here's -3. Here is 5. All right, so this one, this time I'll use open circles. Open circle, shade to the left, and open circle, shade to the right. Now, as far as inequality notation, we'd say, well, this represents x less than -3, but it also represents x greater or equal to 5. I said less than, this should be less than or equal to. No, I'm sorry, it is less than. I'm using the less than's formulation right now. All right, so that's correct. X is less than -3 describes this interval. X greater than 5 describes that interval. And again, where would this show up? If you're talking about what's in the middle, this number in the middle is 1. So there's a distance of 4 between both of them. This set on the number line describes all the points that are a distance of more than 4 units away from 1 on the number line. That's what it describes. All right, but how do I connect this? Well, the word we use in this situation is the word or. And a number falling in one of these sets either lies in one set or the other, not necessarily both at the same time. In this case, it cannot lie in both at the same time, but or means one or the other or both. That's what or is commonly used. It gets a little more complicated. There are inclusive ors and exclusive ors, but we don't need to go into that distinction right now. Just or means, and here I'm using the inclusive or, technically. Or means something belongs in one part or the other, or possibly could belong in both. All right, so or, in order for something to belong in an or statement, only one of these has to be true. If one of them is true, then you're okay. And so, but what about a number in between, like 1? 1 is not less than -3. 1 is not greater than 5. So 1 does not fall into either one of these, so it's excluded. But 1 is, I'm sorry, a number here like -4 is less than -3. It fits in this group, and that's enough to satisfy it. All right, so I have some examples of ands and ors in my book. And if you want to take a little more time to think about that, learn that distinction, and but that's basically it. And or is works differently, and it's good to know that distinction. Now then, there's no way that I've ever seen where we can combine these into one single statement, like we did with the ands. No way to do that. As far as inequalities notation, we would say that x belongs to the interval from -infinity up to -3, and then I'll use a parentheses since it's not including -3, or the interval from 5 to infinity. So there's the interval notation format for that. For that statement there. Okay, well, I'm going to, the next video, we're going to just show you a couple more examples of these, and then we'll move on from there.